Today we're talking about geometric sequences. We've talked about arithmetic sequences. An arithmetic sequence would be one where you are adding some number. So your common difference here would be a 3. That's arithmetic sequence. You add something to get the next number. Geometric sequence, geometric, kind of like geometry, geometric sequence. It doesn't have anything to do with geometry, but it's spelled similar to geometry. A geometric sequence is one where you multiply one term by a common ratio, and the letter we use is R instead of D, to get to the next term. So a really common geometric sequence is 2, 4, 8, 16, 32, and we would say R is doubling. So R is 2. That's a geometric sequence. It's a sequence. It's just separated by commas, not adding at all. Tomorrow we'll do adding geometric sequences, which are called series. But to find the next two terms, you can look to see between 2 and 10. 2 times something is 10. You don't have to do this. Hopefully you can tell it's a 5. R is 5. So the next two terms would be 50 times 5 is 250. 250 times 5 is 1250. For 81 and 108, you can say 81 times something gives 108. And once you know R equals 108 divided by 81, which is 1.3 repeating, or 4/3. Then you can multiply it, so you would have 144 times 1.3 repeating, and you should use several 3's, or you could do 4/3. We would say this is 192, and then we would multiply by 1.3 again. So we'd have 256. You should round it just because we rounded the 1.3 repeating. So 192 and 256. 92, 256. There's that, there's that. Next one, notice the numbers are getting smaller. 162 and going downhill to 108. So you must be multiplying by a number less than 1, fraction. So you have 162 times R equals 108. And the R that we multiplied by would be 108 divided by 162, which is, so 0.6, 0.6, and we get 48 and 32. And the next one, you have fractions. Fractions are pretty easy. When multiplying, you're just multiplying the numerators. So R would be 1 times what is 5, that's 5. And 3 times what is 6, that would be a 2. So 2.5. Multiplying, you have 125 over 24. And 5 times 125 is 625 over 48. And the next example we have, write the first 5 terms. The first 5 terms. You're given the first term is 1, and you're given R, which is what to multiply by to get to the next term. So you'd have 1, 4, 16, 16 times 4, 64 times 4. Be careful with a question like this. Sometimes students will get confused. If the question said A sub 1 is 1, and D equals 4, that's not multiplying by 4. That would be adding 4. So you'd have 1, 5, 9, 13, etc. So it's a different sequence. This is geometric, and this is arithmetic sequence. For this one, we have the first term is 576. Multiply by negative a half, and you would get negative 288. Multiply by negative a half, and you get 144. Multiply by negative a half, you get negative 72. And then you get 36. So they're the first 5 terms of the geometric sequence. Basically, everything in this box is summarizing everything we've just done. So to find R, I usually don't want you to memorize formulas to find R. You should just know intuitively how to find R. But this is basically what we were just doing. like on the previous one, it would be 1 times r, and that gave us the next term, which was 1 times 4 gave us 4. Solving for r, if you have to solve for r, you just divide and solve for r. In words, you can pick any term and divide the term before it to get what the r is. So like on this one, if you pick 144 divided by the term before it, negative 288, you would get what your r value is, negative 1/2. If you want to memorize those, you can. I don't know how helpful they are. This formula, though, is helpful. And there's a typo. This is the nth term of a geometric sequence. The nth term, a sub n, of a geometric sequence with the first term, a sub 1, and common ratio, r, is given by this formula, where a sub n is the last term, a sub 1 is the first term, r is the ratio, and n is the number in the sequence. So for one like this, find the indicated term. You could do it the old-fashioned way and just type it in your calculator, 1/64th. And we're going to multiply by 4, because that's our r, multiply by 4. And we're going to do this until we get to the 9th term. So the first, the second, 3, 4, 5, 6, 7, 8, 9. If I counted right. So 1024. In the sequence of numbers, 1024 would be the 9th term. To use the formula, you'd get the same thing. The formula would be a sub 9 equals 1/64, 4 raised to the n minus 1. And you would get 1024. And pause this video and see if you could do the next one. 1/4 is the answer. We've seen one like this before. What is a sub 6 given a formula? You basically just plug in 6 into the formula and get the answer. On the next page, find the indicated term. Notice that this one, you start with a sub 6. So you could do it the old-fashioned way. You could say if a sub 6 is 3, how do I get to the next term? Well, my r value is 2, so I multiply by 2, multiply by 2, multiply by 2, multiply by 2, multiply by 2. And how many do I do? Well, this is the 6th term, this is the 7th term, the 8th, the 9th, the 10th, the 11th term, and this is the 12th term, a sub 12. So you could list them out. How do we do that with the formula? Because, what if it was the 6th and you would need to find the 150th term? That would take a long time to do that. Well, you would do a sub 12 equals whatever the first term given was, which is really the 6th term, 3. Your r value is 2. And instead of doing 12 minus 1, 12 minus 1 would be the first term is given. You don't do 12 minus 1, you do 12 minus 6, because that is the term that was given. And that will give the same answer, 196. So how about you pause the video and see if you could do the next. The answer is 2. Old-fashioned way up top, and then in red, the formula. Write an equation for the nth term of the geometric sequence. We did these earlier in section 11.1. Notice that you're asked for an equation in terms of n. So you're going to leave the variables with n, leave them alone. So you have a sub n. You don't put anything in for a sub n. Leave it in terms of n. The first term, 64. Our r value, 64 to 16, 16 to 4. You're dividing by 4, which you need to write it as a product. So you're multiplying by a fourth. And you leave this as n minus 1 in terms of n. And that's actually your final answer. It's not really anything that you can simplify. So why don't you try the next one? So a to the n equals 4, negative 3, raised to the n minus 1. Geometric means, we talked about those in section 1. They were arithmetic means before, but geometric means, all that they are missing terms. Missing terms. So find the missing terms. Find the geometric means. Find the missing terms. So we're going to use the formula that we've been talking about today, geometric sequence formula. You might be able to guess and figure out what the number is, but a sub n is the last term, 324. A sub 1 is the first term, 4. R, you don't know. If you knew R, then you could just multiply the first term by R and get the next term. You don't know R. And n, you have 1, 2, 3, 4, 5. So n would be 5 minus 1. So if you divide by 4, you get 81 equals r to the 4th. And to solve for r, when it has an exponent of 4, you would take a 4th root of 81, which is plus or minus 3. And in this case, you actually have to be careful, because if you plug in 3, you would get 12, multiplied by 3, 36, multiplied by 3, 108. But if you multiply by negative 3, that numbers actually still work. 4 times negative 3 is negative 12, times negative 3 is 36, times negative 3 is negative 108, times negative 3 is positive 324. So there's nothing in the problem that we can tell if it's the positive or the negative. So 12 is both positive and negative, and 108 is both positive and negative. And how about you try the next one? So here's the work. R equals 2. It's not plus or minus 2 since it's an odd exponent. R is 2, and there's the geometric means. Last question is about a ball bouncing. It starts at 100 inches. So you can imagine if you had a ball. Here's the floor. If you have a ball and you drop it, started at 100 inches. 100 inches. And it's going to bounce back up, and then it falls 80 inches, and then it's going to be a little lower, maybe lower than that. What was it? 64 inches, and it keeps bouncing and losing the same percent every time. So if it started, the rebound ratio is how much it's rebounding every time. What percent is it rebounding every time? So if it started at 100, multiplying by something, and you would get 80, that means your rebound ratio is 80. So you can think of that as 80% each time. Each bounce is 80% as high as the previous bounce. So if you did 80 times 0.8, you would get 64 for the next bounce. What is the height of the 10th rebound? So you would have A sub 10 is the 10th bounce, 10th rebound. You have 100 for the first term. Your rebound ratio is 0.8, and you raise it to the 10 minus 1. When you multiply, you would get this, 13.42 inches. 422. Okay. 3 decimal places. After how many bounces will the ball rebound less than 1 inch? So notice this question is different. After how many bounces? That is solving for n. After how many bounces? How many terms are in the sequence? 1 inch would be your last term. So you have 1 equals the first term, first bounce, or first height was 100. Your r is still 80%, raised to the n minus 1. We would divide by 100, 0.8 to the n minus 1. And we would log both sides from the previous chapter. So you'd have log of 0.01, which is 1 over 100 as a decimal, equals, bring down the exponent, n minus 1, log of 0.8. And solving that, you divide both sides by log. You have log 0.01 divided by log 0.8 equals n minus 1. And then you'd use your calculator and add 1. And you might get a decimal answer, but you would round to the nearest bounce. So the answer is 22.6, but we say 22 bounces before it is less than 1 inch from the ground. Thank you for watching this video.